Hello everyone, welcome to my channel. Today in this video I'll be proving a theorem which is very important. It also comes in exam, which states that centralizer of an element is a subgroup of a group. So let G be a group. First we'll write a definition of centralizer of element. Let A belongs to a group G. Then centralizer of A is defined as X belongs to G such that AX equal to XA. Now first we have to prove that the centralizer of an element is non-empty. Since in a group we know that there exists an identity element such that the identity element, if you multiply it with the element A, it is always commutative. So since E belongs to C of A, implies C of centralizer of A is non-empty. Now we have to prove that it is closure. So let we'll take two elements, X and Y belongs to centralizer of an element, which will imply that if X belongs to centralizer A, AX will be equal to XA, and if we multiply AY, it will be Y. We'll take this as equation 1. Now let's check it if XY belongs to centralizer of an element. So in order to do that, we'll be seeing that A XY equal to, now we'll be using the associative property AX into Y. Now AX can be written as XA. Now we'll use the associative property again. Now here we can write AY as YA. Now we'll again use the associative property XY into A. So here we can see that A, if we multiply it the element XY is equal to XY into A, which means it is commutative. Therefore XY belongs to centralizer of an element. Now since we have checked the closure property, now we'll have to check if the inverse of all the element exists. So we'll be taking the equation, this equation. We have XA equal to AX. Now we'll be multiplying X inverse on front and back side of both the equations on both sides. So now we'll be using associative property on both sides. here x into x inverse into x is equal to identity. Similarly here x into x inverse equal to identity. So if we multiply any element with identity, the result is the element itself. Similar for this part 2. So here we can see that ax inverse equal to x inverse a, which means it is commutative with a, implies x inverse belongs to the centralizer of an element a. So we can write therefore centralizer of an element is a subset of G. We can't say it's subset. Centralizer of an element is a subgroup of G. Thank you.